It improves their SNDR, their signal to noise ratio, their signal quality. I mean, that's the key, I'm putting a signal into your scope. I want to see my signal. I don't want to see your signal added to my signal. I want to see my signal. So to the extent that we do all these things, they are seeing a more pure representation of their signal. And we call that signal integrity, so that's the name of the game.
Electronics these days are trending toward lower and lower voltages, and the lower noise our signals are, the more accurately they can measure those low voltage signals. The acquisition system in this oscilloscope is so low noise that you may think that it's not working at first. If you look at the oscilloscope behind me, the waveform is so thin it looks like one of the gradical lines.
So the number one contributor to that performance is the preamp. So the Tech61 preamp is primarily responsible for us having very good noise performance at the smaller volts per div setting. So when you zooming in on small signals, the Tech61 allows us to be very, I think, class leading. I would say the next thing that helps us with noise is we have a to D technology that allows us to have a large number of A to sample rate, a very large sample rate. Each ASIC has 100 gigasamples worth of sample rate going on inside of it. And without getting too technical, when you have more samples, it spreads out a lot of the back-end noise of the channel over a larger bandwidth, and then we can filter that out. To go along with good noise, you want to have good horizontal performance too. So along with that, the time base on the 6 series is also very, very, top performance. We have an ovenized oscillator. We got a state-of-the-art phase lock loop ASIC. Very low noise amplification for the clock path. The A to D converter itself also has very, very low jitter. In fact, it's not even a limiting factor, so that it could be just a function of how much jitter was in the time-based design.
We used a very low phase noise crystal oscillator, which in turn makes the sample uncertainty very tight. So the low phase noise is equivalent to jitter in a clocking system, and that low phase noise translates to a more accurate time measurement for our customers.
So now we've got this great foundation that we've laid with our good ASICs and good time base, and now the rest of the system's job is to not mess that up.
Where possible, we use differential routing. Differential routing is less susceptible to crosstalk from other internal sources. Signal comes into the oscilloscope, it has to come in single-ended. So all the single-ended signals are underneath the RF shield and routed with coplanar waveguides to help protect it from any other external noise sources. But once it goes through the preamp, it becomes differential as quickly as possible, and then it's allowed to escape the shielded area. A grounded coplanar waveguide is a routing technique commonly used in RF designs. You route a trace and then you put ground layers on both sides of that trace and then stitch vias through the board to ground. This helps protect the signal from any kind of other external noise sources that might couple into it.
There's a lot of shielding, attention to internal shielding, especially for the front end, which is where all the gain is. So over the Tech61 preamp, it's all covered up with shielding. That helps the noise be good, and it also helps our channel isolation be good. And that's another thing that's way better on this product than previous products. And indeed, any other products by other competitors, our isolation between channels is very good.
We started with the low noise Tech61 preamp. Then we had to keep all the other noise sources from inside the box out. So we developed this RF shield. Then we paid special attention to crosstalk from other channels, from other noise sources inside the box. Like acquisition memory is notably noisy, so we had to shield it from the acquisition memory. We kept power supplies as far away as possible, made sure the power supplies were very low noise.
So, we put a lot of focus into low noise power supply design, a lot of analysis. That comes down to doing a lot of spectral analysis and detailed studies of where all the different spurs are of noise in this frequency domain, and going and knocking those down. The noise in the 6 series is groundbreaking at the small volts per div settings.
Find out more or contact us through Vicom's website.